in this video we're going to be looking at calculating moles and looking at what moles are. First of all, what is a mole when we're talking about chemistry? It's not the mole in the ground, and it's not a mole on your face. It is all to do with an amount of something, an amount of a chemical. So moles is an amount of a chemical. And it's similar to the fact that we know that a pair is two things. So a pair of shoes is two shoes, or you could have a pair of people, it's two people. Similarly, you could have a dozen eggs or half a dozen eggs, and a dozen eggs we know is 12 eggs. It's the same way scientists have used the word mole as a way of describing how much of something, and it's an easy way of being able to compare moles of different chemicals, and it's just being able to compare the amount of atoms within different compounds. So simply, it's an amount of a chemical, and moles is just a type of way of describing how much of a chemical we've got. Now we can calculate moles by using this equation here. So moles equals mass divided by relative formula mass. So we can actually work out, if we have 2 grams of NaCl here, we could work out actually how many moles is that, so we can compare it to something else. Similarly, if we had 6 eggs, that would be half a dozen, and we know that. We don't actually have to do any calculations with that, but it's a similar idea. It's allowing us to compare how many things we've got by using something as a description. So, using this equation, I'm going to do this worked example here. So let me just get the coloured pen. So 2 grams of NaCl. Now, RFM is relative formula mass. If you haven't watched the other video on calculating relative formula mass, I would recommend doing that so that you can complete this here. So relative formula mass is the first thing I would do. So I would look at the big number for Na, which is 23. I'd look at the big number for Cl, which is 35.5. And I'd add them together, which would give you 58.5 grams per mole. So now I've calculated the relative formula mass, and I've got the mass here, so the grams. I can work out moles. So moles is going to equal my mass, which is 2, divided by my relative formula mass, which is 58.5 grams per mole. So you can work out that moles for this one is going to equal, if you put that in your calculator, you'd get 0.034 moles. This is just MOL is how you show moles. If it was asking for that in 2 decimal places, you would put 0.03, because that 4 doesn't round up, so you get 0.03 moles for 2 grams of NaCl. So what have we gone through today? We've looked at the moles is just a way of chemists and scientists comparing the amounts of different chemicals. We've then looked at how we can calculate moles by dividing the mass by the relative formula mass. And relative formula mass is something we looked at in a previous video, so if you're not sure where I got these numbers from and how I calculated this, you might want to go back before having a go at calculating these moles. So what I'd like us to do now is have a go at calculating moles of these 5 things. So we've got the grams, we've got the chemicals. Have a go at calculating how many moles of each we've got. Can I ask that they are done to 2 decimal places? Because it usually asks either 2 decimal places or 2 significant figures, and we'll focus on 2 decimal places today. Okay, so you should now have had a chance to go through that. I'm just going to get a purple pen to show my answers. So the first one, 1 gram of MgCl. Well, first of all, you do your 24 for your Mg and your Cl for 35.5. You'd add them together, and that would give you so the RFM is going to equal 59.5. You'd then do your moles calculation, which is 1 divided by 59.5, which will give you an answer of 0.0168 moles. Have a go at the next one. O2. Well, big number for one of the O's is 16, so it'd be 16 times 2, which would give us 32. And that's grams per mole when we're talking about relative formula mass. Now we know the relative formula mass, you simply put it into the equation, which is mass divided by relative formula mass. So it would be 0.5 divided by the relative formula mass, which is 32. And your answer there would be, let's just check that one because I don't think it looks right with what I've already got. So you do 0.5 divided by 32 is 0.0156 mole. And we're going to go back through and make sure we're at 2 decimal places once I've got all the answers. So 0.75 grams of CO2, so C is 12, oxygen is 16 but times 2, remember. So your RFM here is going to equal 44, and then therefore the calculation would be your mass, which is 0.75 grams divided by 44 grams per mole, which will give us an answer of 0.017 moles. Here, to work out your RFM, there's going to be 2 times 23, because that's a big number for Na. Small number is 16, so you're going to get a total of, when you add those together, RFM is going to equal 81.5. So therefore you're going to do 12 grams, because that's the mass, divided by your RFM, so divided by 81.5 grams per mole, which gives you an answer of 0.15 moles. Final last one, 32 grams of 0.2 oxygen, O2, so that would be 16 times 2, so your RFM equals 32 grams per mole. You're going to do your mass, which is 32, divided by your RFM, which is 32, which will give us 1 mole. Just to go back through and check that we got the correct decimal places, so we need to go back through and just check we've actually answered the question properly. And in this case we've actually missed one of the key parts of the question, which says to 2 decimal places, and it will say that, and you will miss marks if you don't go back over and just check that. So if we're just going to check, that would become 0.02 to 2 decimal places, because obviously the 6 rounds up. Here to get that to 2 decimal places would be 0.02. 0.02 moles again. 0.15. That one's already rounded, and that one's fine. So there you go. That's how we calculated moles. So just to remind you today, what we've done is we've looked at what moles are, and that's just the amount of chemical, a way that scientists compare different chemicals and the amounts of different chemicals we've got. Your equation, that's really important today, is moles equals mass divided by relative formula mass, and then we've gone through and calculated the moles of different chemicals.